have to use this equation to calculate the Kc. Okay, please write this question. So we have the equation as delta G naught is equal to minus 2.303 RT ln K. Okay. Oh, no, RT log K, not ln. RT log K. आप बस Kc नहीं log K का वैल्यू निकाल दीजिए, दैट्स इट. बाकी जब log पढ़ेंगे तो आपको समझ में आ जाएगा. So log K will be equal to minus of delta G naught upon 2.303 RT. (13.8) This is kilojoule. किलोजूल है तो इसको यहाँ पे 1000 से मल्टीप्लाई करना पड़ेगा to get it to joules per mole. With 2.303, R here will be 8.314 into the temperature is 298. इतना कैलकुलेट कीजिए कितना आ रहा है.
Sir?
Yes, tell me.
The numerator will be in minus, right?
Sorry?
Minus?
Minus रहेगा. Yeah, correct. Okay, these are simple questions in which you have some lengthy calculation. That's it. जो calculation में time लगेगा वही ज़्यादा है. Otherwise, this question is easy. If you look at the formula, okay. So log K जो आएगा आपका, that will be equal to minus 2.41. Then you just now need to know how to calculate this. 10 to the power of minus 2.41, and this will be equal to K, right? So K is equal to 10 to the power minus 2.41. आपको बस अभी ये कैलकुलेट करने नहीं आता है ना? वो हम सिखा देंगे तब you will get the answer exactly कि क्या होने वाला है. All of you done? Yes or no? Please tell me.
Yes, sir.
Okay. Right, next. Characteristic of equilibrium constant. Please write number 1. Equilibrium constant is applicable only when the concentration of reactants and products attained their equilibrium state. Okay, so if the equilibrium state is not attained, at that time we define the reaction quotient and not the equilibrium constant. Right, next, equilibrium constant is independent of initial concentration ठीक है, बट ये जरूर दिमाग में रखिएगा, ध्यान में रखिएगा दैट द कंसंट्रेशन जो फाइनल कंसंट्रेशन होना है ना, दैट इज नॉट इंडिपेंडेंट ऑन इक्विलिब्रियम, दैट इज नॉट इंडिपेंडेंट ऑन इक्विलिब्रियम, वो डिपेंडेंट होता है. ओके, इट इज डिपेंडेंट ऑन इक्विलिब्रियम कांस्टेंट. जो भी फाइनल कंसंट्रेशन होता है वी कैन फाइंड इट ओनली थ्रू द इक्विलिब्रियम कांस्टेंट, बट इक्विलिब्रियम कांस्टेंट इज इंडिपेंडेंट. इक्विलिब्रियम कांस्टेंट जो होता है दैट इज इंडिपेंडेंट. राइट, नेक्स्ट, the equilibrium constant has a definite value. Constant has a definite value for every reaction at a particular temperature. ठीक है, so जो equilibrium constant होता है that is temperature dependent. Right, next. For reversible reaction, the equilibrium constant of forward reaction is inverse of the equilibrium constant of backward reaction. So fourth वाले का मतलब है, if I have A that is giving me B, if I am writing the reaction in this way, then I will write the K is equal to, the equilibrium constant is equal to the concentration of B upon the concentration of A. But since this is a reversible reaction, we can also have in some certain aspects B giving A. We are writing the reaction in this way. So अब यहाँ पे जो K dash C हम मानेंगे, ठीक है ना, this is another equilibrium constant, that will be what? That will be concentration of A upon the concentration of B. So this is completely inverse, so I can write this as 1 upon Kc. ठीक है, right, fifth point, the equilibrium constant is independent of the presence of catalyst, independent of the presence of catalyst. Catalyst is just a substance that is used for the increase in the rate of reaction. Okay, so it just fastens the reaction. ठीक है, जो टाइम का एस्पेक्ट है यहाँ पे, जो इक्विलिब्रियम है ना उसका एस्पेक्ट नहीं है कि इट जस्ट सेज दैट कि कब ये रिएक्शन खत्म होगी. कैटलिस्ट है तो जल्दी खत्म हो जाएगा, but the amount of concentration that we are going to have of the product and reactant, that will be in the same ratio जो equilibrium constant determine करता है. So equilibrium constant, it does not get disturbed by the presence of a catalyst. Done, everyone? हाँ जी बताएं. Is everyone done?
Yes, sir.
Yes. Okay. Next topic. Let us suppose I have equilibrium between A and B. Okay. And I started with some amount of A and I left it there. So A, it slowly reacted with itself and it formed B, and we have achieved equilibrium. हमने क्या achieve कर लिया? We have already achieved equilibrium right now. Okay. I have already achieved equilibrium. यानी कि now the concentration of A and the concentration of B is not changing. ठीक है? We have already achieved equilibrium and the concentration of A and B are not. Please listen to this very carefully. Okay. Concentration of A and concentration of B is not changing. हमने ऐसे ही छोड़ा हुआ है. We are not disturbing. Human is not disturbing the system at this particular point of time. But human को हुई चुल, and what did the human did? Human ने डाल दिया थोड़ा सा B और. I added some more amount of B. So if I will add more amount of B, the equilibrium will be disturbed. Yes or no? Please tell me. Correct है? Okay. Who is Faraz? Faraz one.
Yes, sir, it's me, Aisha.
Okay, you are okay, fine, Aisha. Okay. So once we have disturbed the equilibrium. Please remember, अभी तक system ने कुछ नहीं किया है. We human system achieved equilibrium, and what did I do? I added some more amount of B. Okay, I added some more amount of B. Now, what do you think? What is the system going to do? For example, let us suppose I had here the equilibrium was 2/3. ठीक है? So Kc जो होता है क्या होता है? Product upon reactant, right? So for 2 moles of B, there were 3 moles of A, है ना? तो let us suppose हमारे पास यहाँ पे 4 था and 3 2 so 6 हो जाएगा, right? 6. Now I added, let us suppose I added how much? I added 5 moles of B now. ठीक है? तो ये बढ़ के कितना हो गया अब? 9 हो गया, right? सही है? Yes or no? Now the equilibrium is disturbed. तो बताइए K लिखेंगे या Q लिखेंगे? Tell me at this particular time. What should we write? K or Q?
Q.
Q, है ना? Q कैसे define होगा? The amount of B that we have, that is 9/6. Correct? तो ratio क्या आ जा रहा है अभी? 3/2. तो ratio तो खराब है ना? Now you tell me what is going to happen. Forward reaction या backward reaction Q को देख के बताइए. What is going to happen? Kc is equal to how much? 2/3, है ना? And this is 3/2. Forward reaction होगा या backward reaction होगा? This is 0.66, है ना? And this is 1.5. Just tell me, forward reaction or backward reaction?
Backward.
Backward reaction, है ना? So please see, what did the human do? Please tell me, human ने क्या किया? He increased the amount of reactant या product. What did the human do? He increased the amount of reactant या product. क्या increase किया? A या B? बोलिए प्लीज. What happened? फहद अब्दुल्ला, अभी तो बताया हमने क्या किया था ह्यूमन ने. What did he do? He increased the. Yes, Hiba, tell me. Hiba, can you hear me? Can you hear me?
Yes, sir.
I'm asking, what did the reactant, what did the human do? He added some moles of.
B.
Okay. And what did the system do? System converted B to A, है ना? To achieve
Right.
equilibrium, right?
Yes, sir.
The human is increasing the amount of B, and system in response to that, it is decreasing the amount of B and increasing the amount of A. Is that right? Yes or no, please for me. Okay. So this was observed by, and this was formulated by Lee Chateliers. Okay, and he gave the Lee Chatelier principle. Okay, please write the Lee Chatelier principle. So the Lee Chatelier principle says, if a system in equilibrium is subjected to a change, है ना। अब देखिए, इस सब्जेक्टेड टू अ चेंज का मतलब है इफ ह्यूमन इज गोइंग टू इंटरफेयर, बाकी और कौन है दुनिया में हमारे अलावा, राइट? देयर इज नो वन हु इज गोइंग टू सब्जेक्ट सम चेंज. Human is only going to interfere in the equilibrium. So if a system is in equilibrium, is subjected to change in any of the factors that determine the equilibrium conditions, that determine the equilibrium conditions of a system, है ना। जैसे कि मान लीजिए अभी आपने B का अमाउंट इंक्रीज किया, व्हाट डिड द ह्यूमन डू? ही इंक्रीज द अमाउंट ऑफ B. सो व्हाट डिड द सिस्टम, है ना, सिस्टम ने क्या करेगा? सिस्टम ने B से A बनाया. अगर हम A की अमाउंट इंक्रीज करते हैं, सिस्टम क्या करता है? A की अमाउंट को डिक्रीज करते हैं, B में कन्वर्ट करता है, राइट? सो एनी ऑफ द फैक्टर्स, reactant, product, okay, you will see some more factors that determine the equilibrium conditions. The equilibrium condition of a system, then the equilibrium will shift in the direction so as to reduce or to counteract the effect of change. है ना। आई होप ये स्टेटमेंट अब समझ में आ गया होगा once we have already explained the phenomena, है ना। कि if I am doing some change, तो what the system is going to do, it will shift. देखिए, इक्विलिब्रियम का शिफ्ट होने का मतलब नहीं कि इक्विलिब्रियम कांस्टेंट चेंज हो जाएगा, प्लीज रिमेंबर दैट. इट इज सेइंग दैट जो इक्विलिब्रियम है ना, वो सिस्टम को बोल रहा है. इक्विलिब्रियम क्या करेगा? इट विल शिफ्ट इन दैट डायरेक्शन जो क्या करे, द चेंज को रिड्यूस कर दे. सो इफ यू हैव इंक्रीज द अमाउंट ऑफ बी, इट विल डिक्रीज द अमाउंट ऑफ बी एंड इट विल कन्वर्ट इट टू. सो इट इज डूइंग बोथ ऑफ दिस थिंग्स. इट इज रिड्यूसिंग द चेंज that you have increased the amount of B, so that is being reduced by reducing the amount of B, and it is also counteracting by it is increasing the amount of A. So both of these things are happening. Please let me know if you have not understood, otherwise we will move forward. Clear sabne? Let me know if you have not written and write. The first condition that we are going to look at is the concentration. So in concentration, we can have reactant. We can increase the amount of reactant, or we can decrease the amount of reactant. If I increase the amount of reactant, ठीक है, then देखिए, अगर हमने A का increase किया amount, तो क्या होगा? A से B में convert होगा, तो forward direction. So the system will shift towards forward direction. If I decrease the amount of A, then system क्या करेगा? B से बोलेगा तुम please A बन जाओ थोड़ा सा, so that I will have some more amount of A, है ना, और equilibrium achieve हो जाए. So if I decrease the reactant, then backward reaction will happen. Okay, then you have products. Now, in products also I can increase and decrease the concentration. If I increase the concentration of product, that means there will be backward, the equilibrium will shift or the reaction will go towards backward direction. And if I decrease the amount of product, then it will go to the forward direction. Please let me know if you have not got this point about reactant and product increase or decrease करने से क्यों change आ रहा है. Okay, and write this down. Done everyone? Yes or no? Please tell me. Okay, let me know if I'm not done and write this question. Write the answer in chat, okay? Yes, very good, Heba. फहद आपसे नहीं हो रहा है? फहद, अब्दुल्ला, आयशा. Yes, Fahad. Seems he's not here. Backward. Yes. Very good, Heba. That is right. Check. Now let us see another type of reaction. Okay. If you remember, there are two, generally speaking, there are two types of reaction. It can be exothermic or endothermic. If I talk about the heat requirement, ठीक है? तो दोनों का हम लोग देखते हैं. I have A giving me B. Okay. And this reaction is exothermic. That means it is also going to give me some heat. Similarly, this is example of exothermic. Okay. And now let us suppose we have some reaction which is endothermic. That means you have A that is giving you B, but whose camera is on? A that is giving you B, but this requires also some amount of heat. Okay, this also requires some amount of heat, and this is what this will be endothermic. This will be endothermic. Okay, now listen. See, when heat is given, ठीक है, that means हम बोल सकते हैं कि there is some temperature increase. Okay, there is some temperature increase, and when heat is taken by the system, तो फिर क्या हो रहा है आपका? Then we can say that there is some increase in the temperature in the reactant side. ठीक है, अब ध्यान से सुनिएगा. If I increase the temperature here, the reactant side, हमने क्या किया? इस वाले endothermic process में I increase the temperature. है ना? तो reactant और product तो temperature के लिए नहीं होगा. The temperature will increase of the whole system, right? But coincidentally, endothermic में heat की requirement कहाँ पे? Reactant में. So heat is acting as a reactant, and if heat is acting as a reactant and I am increasing the temperature, that means heat क्या हो रहा है? बढ़ रहा है. That means the amount of reactant is increasing, and that is why the reaction will be what? Forward or backward? Tell me. जब reactant की concentration increase करते हैं, if I increase the amount of reactant, then what is going to happen? Forward reaction or backward reaction?
Forward.
Forward reaction. Okay. So if you increase the temperature in an endothermic process, then what is going to happen? Forward. ठीक है, अभी लिखिएगा मत. And similarly, if you increase temperature in an endothermic process, तब क्या हो रहा है? Heat कहाँ पे increase कर रहा है? It is increasing in the product side. So that is why the reaction will be what? Backward. Clear है? Yes or no? Please tell me.
Okay.
Okay. Right. Next. Second जो है temperature. Now, temperature जो है आपका that can increase or decrease. Now, if the temperature is increasing, then the equilibrium will shift towards endothermic reaction. Shifts towards endo reaction. अगर decrease होगा तो shifts towards exo reaction. ठीक है, जैसे कि मान लीजिए अगर आप यहाँ पे देखें तो forward reaction, that is what is that? Forward is endothermic, और अगर हम backward देखें तो backward reaction is exothermic, है ना? तो अगर हम इंक्रीज कर रहे हैं टेम्परेचर तो किधर शिफ्ट हो रहा है? इट इज शिफ्टिंग टुवर्ड्स द एंडोथर्मिक, और अगर आप टेम्परेचर को डिक्रीज कीजिएगा देन इट विल शिफ्ट इन दिस डायरेक्शन. ठीक है, तो एक्सोथर्मिक की तरफ वो शिफ्ट हो जाएगा. नाउ इफ यू हैव एन एक्सोथर्मिक रिएक्शन, तो यहाँ पे टेम्परेचर अगर आप इंक्रीज करेंगे देन यू आर गोइंग टू हैव backward reaction will move toward backward direction, and if temperature is decreased then the reaction will move towards forward direction. ठीक है, after the equilibrium has been established. उसी तरह से अगर आपके पास एंडोथर्मिक रिएक्शन है, then on increasing the temperature the reaction will move forward, and on decreasing the temperature the reaction will move backward. Done? हाँ जी बताएं. चलिए, I hope you have written this. Right, next देखो, Now I will talk about pressure, but pressure अगर आप देखिए एक एग्जांपल से, नाइट्रोजन गैस plus 3 moles of hydrogen. Nitrogen is also gas. This is an equilibrium with 2 moles of ammonia. Okay, 2 moles of ammonia. So here we have more moles of gas. Can you see that? यहाँ पे 1 mole gas का, and here we have 3 plus 1, 4 moles of gas. So we can say here we have more moles of gas, and here we have less moles of gas. Correct? Yes or no? Please tell me.
Yes.
ठीक है? Now, if I am going to increase the pressure, then what is going to happen in that case? If I am going to increase the pressure, तो pressure increase होगा. System will क्या चाहेगा? This is from human, right? From human, after we have established the equilibrium, then the system will try to decrease the pressure. ठीक है? System will try to decrease the pressure. बताइए, which part? More moles of gas will decrease the pressure या less moles of gas will decrease the pressure? Pressure कम कहाँ पे होगा? If you have more amount of gas, pressure वहां पे कम होगा या वहां कम होगा जहां पे less amount of gas है? Where will we have less pressure? More moles of gas or less moles of gas? Because system को क्या चाहिए? System needs to decrease the pressure. So tell me, where do we have less pressure? More moles of gas में या less moles of gas में? Yes, correct. Fahad. What about others? वजिया आई हैं. वजिया आप बताइए, यहाँ समझ में आएगा? ठीक है, थोड़ा लेट आई थी आप कभी. बताइए कहाँ पे आपको लेस प्रेशर मिलेगा? इफ यू हैव मोर गैस तो प्रेशर ज्यादा होगा या कम गैस में ज्यादा प्रेशर होगा? आयशा, हिबा, अब्दुल्ला, ऑल ऑफ यू आंसर प्लीज. Yes, correct. है ना? I hope it is very intuitive that if you have less moles of gas, then the pressure will also be less. That is why if you increase the pressure, है ना? Human क्या कर रहा है? It is increasing the pressure. System क्या करेगा? It will decrease the pressure, and if it is decreasing the pressure, it can decrease the pressure only by moving from more moles of gas to less moles of gas. हम ये नहीं बोल रहे forward जा रहा है. हमने ये नहीं कहा कि forward जा रहा है. I'm saying that it will move towards less moles of gas. That side which is having less moles of gas. Similarly, if I decrease the pressure, तब क्या करेगा? It is going to go towards the that direction where you are getting more moles of gas. Okay, चलिए, right, next. Third है pressure. Right. प्रेशर को आप क्या कर सकते हैं? इंक्रीज कर सकते हैं, एंड प्रेशर को आप क्या कर सकते हैं? डिक्रीज भी कर सकते हैं. So if you are going to increase the pressure, then it will move towards less number of moles of gases. This will move towards more number of moles of gases. ठीक है? Done everyone? Yes or no? Please tell me. चलिए फिर हमने लिख लिया प्रेशर, है ना। फोर्थ लिखिए, एडिशन ऑफ इनर्ट गैस। ठीक है, इनर्ट गैस का क्या मतलब है? व्हाट इज द मीनिंग ऑफ इनर्ट गैस? विल इट टेक पार्ट इन द रिएक्शन? टेल मी यस और नो।
No.
नो, इट विल नॉट टेक पार्ट इन द रिएक्शन। तो फिर क्या करेगा अगर आप गैस ऐड कीजिएगा, तो क्या करेगा वो? See, there are two ways in which you can add an inert gas. ठीक है, this is a movable piston. If you want to keep the pressure constant, you have added inert gas. If you want to keep the pressure constant, आपने गैस ऐड किया तो प्रेशर तो ऑब्वियसली इंक्रीज करेगा. So in order to keep the pressure constant, what you have to do, you have to increase the volume. ठीक है, एक तो एडिशन होगा इनर्ट गैसेस का, किससे? एडिशन ऑफ इनर्ट गैस इन कांस्टेंट प्रेशर. दूसरा हो सकता है एडिशन ऑफ इनर्ट गैस इन कांस्टेंट वॉल्यूम. हमने वॉल्यूम यहाँ पे चेंज नहीं किया, दिस इज सील्ड. ठीक है, इन कांस्टेंट वॉल्यूम. अब बताइए कहां पे चेंज आएगा, कहां पे चेंज नहीं आएगा? ठीक है, सुनिए यहाँ पे फिर से आराम से. When your volume is constant, ठीक है, when the volume is constant, we can say the moles of reactant and product are also constant, है ना, because inert gas is not taking part in the reaction, है ना. उसको क्या मतलब, whatever number of moles of reactant are there or number of moles of product are there, that is also same. The number of moles भी same है, volume भी same है, therefore concentration also remains same. Clear है ये सर? अभी हाँ जी बताएं, सेम है, कंसंट्रेशन भी सेम है, राइट? ये समझ में आया कि नहीं आया ये बताइए पहले. इन कांस्टेंट वॉल्यूम, in constant volume the number of moles of reactant and product are also same, because number of moles of reactant and product हम change नहीं कर रहे हैं, equilibrium has been established and that is as it is, है ना. तो number of moles भी change नहीं हो रहा है, constant volume है तो volume भी change नहीं हो रहा है, therefore the concentration also remains same and hence there will be no change. मतलब कुछ आप inert gas add करने से there is going to be no change. Okay, so आपका ना ही equilibrium में कोई effect आने वाला है. So you'll write therefore no effect on equilibrium. But when you add an inert gas at constant pressure, in this case, what happened? The volume increases. Therefore, concentration, which is equal to number of moles upon volume, this concentration is going to what? This concentration is going to decrease. है ना? तो concentration जब decrease हो जाएगा, then what is going to happen? Therefore, equilibrium will shift. किस तरफ शिफ्ट करेगा? तो उस तरफ शिफ्ट करेगा जहां पे आपके पास मोर नंबर ऑफ मोल्स ऑफ रिएक्टेंट हो या मोर नंबर ऑफ मोल्स ऑफ प्रोडक्ट. ओके, सो वी विल राइट equilibrium will shift towards the direction in which more number of moles of gas is present. ठीक है, इन शॉर्ट इनर्ट गैस में क्या हो रहा है, at constant pressure it will shift towards more moles of gas, and at constant volume there will be no effect. ठीक है, तो आप लोग अपना काफी सारे सवाल कर सकते हैं। आई थिंक यू कैन डू, अगर हम स्टार्ट करें एनसीईआरटी में, एटलीस्ट हाफ ऑफ द क्वेश्चंस यू कैन डू टिल स्टार्टिंग से देखें। अगर हम इक्विलिब्रियम पार्शियल प्रेशर्स है ना, पहले सबसे इनिशियली तो यू जस्ट हैव टू कैलकुलेट द कंसंट्रेशन, इक्विलिब्रियम कंसंट्रेशन कैलकुलेट करना है या फिर आपको केसी केपी कैलकुलेट करना है, दैट इज इट। सो डज द नंबर ऑफ मोल्स ऑफ reactant decrease in pressure by increasing the volume? एक और देख लीजिए आप, राइट हियर वॉल्यूम, नेक्स्ट क्या लिखिएगा, फिफ्थ पॉइंट वॉल्यूम। सी वॉल्यूम का इफेक्ट ना डायरेक्टली नहीं होता है, इट इज इनडायरेक्टली ओनली वाया प्रेशर। सो ऑल्सो वॉल्यूम का जो इफेक्ट है that is not given in NCERT text में, but it is there in one of the questions. Okay, so please write volume. Now volume you can increase or decrease. Okay, when the volume is going to increase, pressure is going to decrease, right? If the pressure is going to decrease towards more moles of gases, towards more moles of gas. देखिए, आई होप मे बी स्टेट्स ऑफ मैटर नहीं किया तो उतना इंट्यूटिव नहीं होगा आपके लिए। आप देखिए इस तरह से, यहाँ पे प्रेशर ज्यादा होगा या फिर यहाँ पे प्रेशर ज्यादा होगा। अगर आपने बड़ा सा बॉक्स लिया, सेम नंबर ऑफ मोल्स ऑफ गैसेस हैं, तो ऑब्वियसली यू कैन से जहाँ पे छोटी चीज है, लाइक व्हेन यू हैव स्मॉल वॉल्यूम, इन दैट केस द प्रेशर इज मोर। सो इफ यू आर इंक्रीजिंग द वॉल्यूम, प्रेशर इज डिक्रीजिंग, देयरफॉर इट इज गोइंग टू टुवर्ड्स मूव टुवर्ड्स मोर मोल्स ऑफ गैसेस। अब जब डिक्रीज कीजिएगा, देन इट विल मूव टुवर्ड्स लेस मोल्स ऑफ गैस। What else you can do? 7.25 कर सकते हैं, 26 कर सकते हैं, 27, 28 कर सकते हैं, 29 तो करा दिया हमने आपको, 30, 31, 32, 33, 34 तक आप लोग कर सकते हैं आराम से, बिल्कुल। अब ओके, सो 7.34 till here you can try all the questions in NCERT. ठीक है, उनका आंसर आपके नोट्स में ही है। अगर आपको ये पे दिक्कत आएगी तो those things are present in your notes only. ठीक है, and this was the end of chemical equilibrium. ठीक है, this was the end of chemical equilibrium. नेक्स्ट है आपके पास ionic equilibrium. Okay, so write the topic ionic equilibrium. Ionic equilibrium. Now, ionic equilibrium, we are going to talk about ions, है ना? और ions कहाँ से आते हैं? Electrolytes से ions आते हैं। What are electrolytes? Electrolytes are those substances that conduct electricity in molten state or aqueous state. Those things are known as electrolyte. The substance that conduct electricity in molten state or in aqueous state is called electrolyte. Is called electrolyte. Okay. For example, you have sodium chloride, sodium hydroxide, HCl, KOH, MgCl2. All of these are electrolytes. Electrolytes में आपके पास, for example, let's take a basic example of NaCl. NaCl is going to be dissociated into Na plus and Cl negative, right? So, ये NaCl is my electrolyte, and these are the ions. और इन्हीं के बारे में हमको पढ़ना है. हमको किसके बारे में पढ़ना है? We have to learn only about these ions. Now, depending on the percentage dissociation, if I have an electrolyte and I put it in water, है ना, इसको हमने water में डाल दिया, so I will get Na plus and Cl negative. So they are going to dissociate into the ions. On how those electrolytes are getting dissociated, it is getting dissociated completely or partially. On that basis, the electrolytes are divided into two categories. Electrolytes को divide करेंगे दो हिस्सों में. There are strong electrolytes and there are weak electrolytes. ठीक है? Now, strong electrolytes, they dissociate completely. Weak electrolytes, they dissociate partially. ठीक है? ध्यान से देखिए. Strong electrolytes, I'm giving examples. Try to at least remember one or few of them. Okay, one or two of them, please इनको याद रखिएगा. Strong में भी, weak में भी. Strong generally आपको याद रहेगा NaCl, KBr, HCl, H2SO4, MgCl2. All of these are examples of strong electrolytes. Weak electrolytes में आपके पास generally होंगे, these will be organic acid, organic bases type से होंगे. So you'll have CH3COOH, acetic acid, ethanoic acid, NH4OH. Then you have HCN. You have ammonia. Okay, all of these are what? All of these are, we can classify them as weak electrolyte. But again, this is a spectrum. ऐसा बिल्कुल black and white नहीं होता है कोई भी चीज, ठीक है? Strong and weak. Generally speaking, जो आपके पास, if you have a metal and a non-metal, अगर metal और non-metal का bond बन रहा है, then it is going to be, and also metal of what? Group 1 and group 2. ठीक है? और आपके पास non-metal of what? Non-metal of, let us suppose the halogen non-metals. Those are going to form good, strong electrolytes. Okay, but all the organic ones, they are going to be weak electrolyte. They do not dissociate completely. Now, if you look at this complete scenario here, okay, if you look at this complete scenario here, you have got NaCl, you have got KBr, HCl, H2SO4, MgCl2, CH3COH, NH4OH, HCN, and NH3. Now, all of these electrolytes are either acid, or they are base, or they are what? Salts. है ना? NaCl salt है, HCl acid है, H2SO4 acid, MgCl2 salt है, CH3COH क्या है आपके पास? This is an acid. ये आपके पास base है, ये आपके पास base है, ये आपके पास acid है. It is either an acid or a base or a salt. ठीक है? Now, अब electrolytes से हम लोग क्या करते हैं? That is why we move towards, since all of these electrolytes, they are either an acid or a base or a salt, and a salt can be prepared from what? And a salt can be prepared from acid and bases. So इससे अच्छा कि हम strong weak इतने सारे electrolytes को पढ़े. We will just study the acid and base because acid and base भी क्या होता है? Acid and base से salt बनता है. Okay, so we'll learn about acid and bases to learn the electrolytes. Why? Because all the electrolytes are either acid or bases or salt, and salt is made by acids and bases only. That is why we start with acid and bases. ठीक है? अब लिखिएगा acid base concepts. I hope you understand the chain कि क्यों electrolyte था, electrolyte से फिर आपने electrolyte से फिर strong and weak electrolyte था, फिर हम लोग acid base कहाँ से आ गए? Acid base इस वजह से आया because all of these things are either acid or base or a salt of it. Right, next, acid base concepts. Now, in acid base concept, you will write number 1. Arrhenius concept. Okay, number 1, Arrhenius concept. What does Arrhenius say? Arrhenius said that simple सा उसका फंडा था. Acids give H plus ions. Bases give OH negative ion. कहाँ पे? In water. Ions in water, and this is also in water. Now, Arrhenius concept was a bit what Arrhenius का जो concept था ना, that is going to be a bit limited because जब तक आप पानी में डालेगा पता नहीं चलेगा क्या acid और base क्या है. Okay, so Arrhenius concept was the first concept, and all the chemistry at that time was aqueous chemistry. It was done in water. That is why all the acid that it liberated H plus ions and bases उन्होंने classify किया OH negative ions. Okay, next is जो आपके पास ज़्यादा important होगा, that is Bronsted-Lowry acid base concept. Now, Bronsted-Lowry, he said that they said acids give, or we can say loses H plus, ठीक है, और bases क्या करते हैं? Bases accept और gain H plus. इन्होंने बोला कि इतना हम OH negative और H plus नहीं करते हैं. उन्होंने Bronsted-Lowry, they observed that whatever is giving OH negative जा रहा है H plus के ही पास, right? So if it is giving OH negative and it is attaching on H positive, तो let us just summarize the information और इसको थोड़ा सा concise कर देते हैं. Acid will give H plus, base will accept H plus. Okay, acid will give H plus and base will accept H plus. अब इससे क्या हुआ? There are a few things. For example, ammonia. ठीक है? See, ammonia we have NH3. NH3 is it is a base, but it does not give OH negative. Okay, so Arrhenius concept was not able to explain NH3, ammonia ka basic nature. But Bronsted-Lowry will easily explain. We'll say that you have NH3 with a lone pair here and H positive. Now, since NH3 is accepting a H plus ion, it is becoming NH4 positive. That is why NH3 is a base. ठीक है? तो वहां से क्या हुआ? We can now say that NH3 is a base. Now, there is a few things Bronsted-Lowry also explained. After defining acids and bases, देखिए, एक example में आप देखिए. If I add a reversible nature to this particular reaction, now I am looking at the forward direction. Forward direction, I am looking at the forward reaction, and I am saying that NH3 is a base. Okay, why? Because it is accepting H plus. But if I look at the backward direction, तब बताइए यहाँ पे, what is NH4 positive doing? It is losing H plus. Yes or no? Please tell me, all of you. Can you see that? It had 4 hydrogen. Now nitrogen has 3 hydrogens only. It is losing H plus. Yes or no? Correct, guys? Can all of you see that? Yes or no? Tell me. Hiba, Fahad, Aisha, Abdullah, Waziha.
Yes, sir.
है ना? तो अभी ये NH4 positive, this is acting as what? It is acting as an acid. अब इस pair को, now this base and this is the, we said this is the base, and ये acid है इस base का, that is why this is known as conjugate acid. ओके, व्हाट इज कॉन्जु, अभी डिफाइन ऐसे उन्होंने डिफाइन किया, सारा एक्सप्लेनेशन दे देंगे, ठीक है, बट राइट दिस कॉन्जुगेट एसिड। ही आल्सो डिफाइन conjugate acid base pairs. अभी ये NH3 और NH4 positive, these are pairs now. He said that conjugate, right here, conjugate acid base pairs, है ना। अब उन्होंने कैसे डिफाइन करेंगे व्हाट इज कॉन्जुगेट एसिड कॉन्जुगेट बेस में, सी हियर, add H plus to make conjugate acid, और किसी चीज से भी अगर आप इफ यू रिमूव H plus to make conjugate base, ठीक है। अब यहीं से आपका सवाल एक है 7.34 और 7.35 में ही है इन योर NCERT। उन्होंने बोला व्हाट इज मेंट बाय कॉन्जुगेट एसिड बेस पेयर, ठीक है। देन दे आर आस्किंग फाइंड द कॉन्जुगेट एसिड बेस फॉर द फॉलोइंग स्पीशीज।
So,
हाँ हाँ जी बताएं।
in the above reaction, the NH3, NH3 acts as both a base and an acid.
NH3 नहीं, NH3 तो बेस है,
Okay. Oh.
NH4 पॉजिटिव एसिड की तरह काम कर रहा है लेकिन,
So,
है ना?
but it's accepting and gaining.
Sorry, but it is
It's accepting and gaining H plus, right?
NH4, right? Yeah, NH4 positive ना? Yeah. NH4 पॉजिटिव नहीं एक्सेप्ट कर रहा ना, NH3 एक्सेप्ट कर रहा है हाइड्रोजन को, राइट?
Oh, yeah. Okay.
है ना, मेक सेंस?
Yes.
ठीक है, पर्सपेक्टिव होता है थोड़ा सा कंफ्यूज मत होइए। फ्रेम ऑफ रेफरेंस लेके चलिए, है ना, फिजिक्स से फ्रेम ऑफ रेफरेंस लेके आइए, यहाँ पे अप्लाई कीजिए। Write the question, write the question. ठीक है, व्हाट इज मेंट बाय कॉन्जुगेट एसिड बेस पेयर, प्लीज नहीं। ये जो कॉन्जुगेट एसिड बेस पेयर होगा ना, जैसे आपके पास मान लीजिए NH3 और NH4 पॉजिटिव है, सो दे डिफर ओनली बाय वन प्रोटॉन, है ना, एक में प्रोटॉन कम, एक में प्रोटॉन ज्यादा। सो दोस पेयर्स दैट व्हिच डिफर ओनली बाय one proton, those are known as conjugate acid base pair, is right? The acid base pair, the acid base pair that differ only by one proton are called conjugate acid base pair, ठीक है। अब जैसे देखिए आपके पास है HNO2, ओके, HNO2 में इफ यू ऐड एसिड, इफ यू ऐड H प्लस, ठीक है, आपने H प्लस ऐड कर दिया, दिस विल बी नाउ HNO3, नहीं, H2NO2 पॉजिटिव हो जाएगा ये, राइट? H2NO2 पॉजिटिव हो जाएगा ये, राइट? इफ यू रिमूव द H प्लस, दिस विल बी नाउ NO2 नेगेटिव, ठीक है। यहाँ पे आपने H प्लस को ऐड किया है और यहाँ पे आपने H प्लस को रिमूव कर दिया है, देन यू हैव Cn नेगेटिव। Cn नेगेटिव में आप H प्लस ऐड कीजिएगा, दिस विल बिकम HCN। रिमेंबर हियर Cn नेगेटिव से आपने क्या किया, H प्लस को डाला, राइट? यू एडेड H प्लस, यू गॉट HCN, ठीक है। बट इसका आपके पास Cn का ये पेयर नहीं बनेगा, यू विल नॉट गेट द, यू कैन नॉट रिमूव हाइड्रोजन बिकॉज यहाँ पे है ही नहीं, ठीक है। सिमिलरली इवन इन दिस केस HNO2 में भी आपने यहाँ पे जबरदस्ती ऐड कर दिया, ऐड हो सकता है HNO2 में, देयर इज नो डाउट इन दैट, यू कैन ऐड H+, आप लोगों ने इसमें देखा होगा। इफ यू रिमेंबर द नाइट्रेशन ऑफ बेंजीन रिंग्स, नाइट्रेशन ऑफ बेंजीन में HNO2 रहता है, वहां पे H+ ऐड होता है ना। वैसे अब देखिए यू हैव OH नेगेटिव, OH नेगेटिव में दोनों चीज कर सकते हैं आप, आपने H+ ऐड कर दिया, दिस बिकेम वाटर, and you can remove the hydrogen from here, but it does not happen generally. Similarly, आपके पास CO3 2 negative है, आप यहाँ पे हाइड्रोजन ऐड ही कर सकते हैं बस, you will get HCO3 negative. HCO3 negative में एक और बार हाइड्रोजन ऐड कर ली, you will get H2CO3. I hope you can understand that the positive charges जो है, negative charge अगर कहीं पे तो H+ ऐड होके that is becoming neutral, and that is why you are having HCN and H2O. OH negative में negative charge नहीं है, because I am adding H+, which is neutralizing the negative charge. Write this down. एक similar सवाल है आपका 7.3837 में शायद है, let me see, 7.37 and 38. Moving on, there can be a few things which are amphoteric in nature. Amphoteric का मतलब क्या होता है? Which can act both as acid and also as base. For example, water है, ठीक है? तो water में if you add H+, it will get H3O positive, which is an acid, conjugate acid हो गया अब, and if you remove the H+, तो ये OH negative बन जाएगा, that is the conjugate base, ठीक है? So these type of species, these right substances that can add as well as remove H+, and hence can act as acid and bases, acid and base, are called amphoteric substances. Done everyone? अब देखें. Now we are going to talk about strong acid and strong base, weak acid and weak bases. ठीक है? Now see, I'm giving you example of an acid. एक acid है, इसके पास क्या होगा? You will have H attached to it, right? H will be attached to the acid. Now, this is going to dissociate, right? Sorry. H+ निकल जाएगा and the electron will go towards A negative. So you will get A negative and H positive once you have removed the hydrogen. So this is the acid. और ये क्या हो जाएगा acid का? Tell me, ये pair क्या कहलाएगा? What will be A negative known as? जल्दी बोलिए, जल्दी बोलिए. A negative क्या हो जाएगा फिर? क्या पेयर बताया था? Acid base पेयर होता है ना, तो ये acid और ये कैसा base? This is a base, but what kind of base? Please tell me. What type of base? Fahad, Hiba, Waziha. Yes, Waziha. आवाज नहीं आ रही है आपकी। हिबा बताइए कैसा बेस है ये?
Conjugate.
हाँ, नाउ यू आर ऑडिबल वजीहा। जी बताइए वजीहा।
Conjugate base.
हाँ, वेरी गुड, दिस इज कॉन्जुगेट बेस। ठीक है, ध्यान सुनिएगा आप। ओके, ऑल ऑफ यू प्लीज लिसन वेरी केयरफुली। इफ A negative is unstable, what I am saying, if A negative is unstable, यानी कि it cannot bear the negative charge, उससे रहा ही नहीं जा रहा है, उससे it cannot bear the negative charge, that is why what it will do, it will react with H plus and ये वापस से क्या बना लेगा, एसिड बना लेगा, है ना? Yes or no? It will form AH. That means if my A negative is unstable, it is going to attack on the H plus and it is going to form back the acid. तो भाई एसिड का काम क्या होता है? H plus में डिसोसिएट होना, राइट? H plus को डिसोसिएट करना, H plus को लिबरेट करना. If the acid is liberating or giving H plus easily, then it is strong. सही है? All of you agree with this statement? Yes or no? Please tell me. If the acid gives the H plus easily, then only it is strong. If it is not giving the H plus, then kahe ka acid? Correct? Yes or no? Please tell me. All of you understand this rule? If the acid is giving H plus easily, then only it is strong. Yes or no? Please tell me.
Yes, sir.
Okay. Now, when my A negative is unstable, आप लोग को ये भी समझ में आ रहा है? If the A negative, the conjugate base is unstable, that means it is not able to bear the negative charge. So it will go and run towards H plus ion, and it is going to form back the acid because it cannot bear the A negative charge. But if my conjugate base is stable, it can easily bear the A negative charge. So it is very calm. It is not going toward H plus. The acid is liberating H plus. The acid is saying H plus, I don't need you. I am stable even if I have A negative. And that is why we can say that that is a good acid. So please remember, strong acids have stable देखिए, एक और चीज हम स्टेबल के बाद लिखने चाहेंगे, उसको भी हम एक्सप्लेन कर देते हैं अभी। प्लीज रिमेंबर, प्लीज सी। If A negative is accepting H plus, that means it is a base. If A negative is accepting H plus, that means it is a base. And if the A negative was very unstable, then it will go and it will easily attach with H plus. It will easily attack on H plus. It will easily gain the H plus if it is unstable. If A negative is unstable, it cannot bear the negative charge, then it is move forward and it will attack on the H plus and gain the H plus. At that time, A negative is acting as a base which is accepting the proton. And since it is accepting the proton easily, it will be a good base. Now, please see what I said. If A negative is unstable, it is going to attack on H plus and it is going to be act as a good base. But if my A negative is stable, it is not reacting anywhere. It is not going towards H plus also. It is not acting as a base also. That is why I will say it is a very weak base. Strong acids have stable and weak conjugate base. Similarly, strong base have stable and weak conjugate acid. उसी तरह से हम क्या लिख सकते हैं? Weak acid have unstable and strong conjugate base. Weak base have unstable and strong conjugate acid. ठीक है, स्टेटमेंट्स को लिख लीजिए। What is strong acid? Easily loses H plus. Strong base easily gains H plus. चलिए काफी इतना. Mostly we will deal with Bronsted-Lowry acid-base concept. That is why it is in such a detail. Next, we also have a Lewis concept of acid and bases. That is important, but उसके बारे में extensive details नहीं है. हम लोग जितने भी acid और bases की बात करेंगे, those will be always, mostly those will be Bronsted-Lowry acid bases. चलिए, moving on. Lewis concept of acid base. लुइस ने और भी आसान कर दिया. लुइस ने कहा एसिड्स एक्सेप्ट इलेक्ट्रॉन पेयर. इनको नाम दे दिया दीज आर इलेक्ट्रॉन पेयर एक्सेप्टर. एसिड्स क्या होते हैं? इलेक्ट्रॉन पेयर को एक्सेप्ट करते हैं. व्हाट आर बेसिस? बेसिस डोनेट इलेक्ट्रॉन पेयर या फिर इलेक्ट्रॉन पेयर डोनर. आपके पास एसिड है एंड बेस है. बेस के पास क्या होगा? एक एक्स्ट्रा इलेक्ट्रॉन पेयर होगा, वो एसिड को देगा और एसिड को हम पॉजिटिव चार्ज दे देते हैं, राइट. यहाँ पे क्या हो जाएगा? अब ये ए और बी के बीच में बॉन्ड है ना, ए और बी के बीच में बॉन्ड हो जाएगा, बी को नेगेटिव चार्ज दे देते हैं, तभी तो इसके पास इलेक्ट्रॉन पेयर आता है. जहां तक बात है लुइस बेसिस की, ये सिर्फ दो ही टाइप के हो सकते हैं. Can be only of two type. This will be neutral atoms with lone pair. Or it can be anions. For example, NH3 जो है, this can act as what? Lewis acid. Sorry, can act as Lewis base. Water can act as Lewis base. Amines can act as Lewis base, RNH2. Okay. Similarly, alcohols can also act as Lewis bases. Anions की बात अगर हम करें, so you can have OH negative, Cn negative, Cl negative, Br negative, right? All of these things can act as what? All of these things can act as Lewis bases. Next लिखिएगा. Now, Lewis acid की category में we have multiple contenders here. Lewis acids. Lewis acid में सबसे पहले आते हैं incomplete octet वाले. Incomplete octet. Here we have BF3. BF3 में incomplete octet, that is why one of the orbital is vacant and there we can put in some electrons. So BF3 हो गया, AlCl3 हो गया. You can have FeCl3, right? These are important for organic chemistry also. You can have FeBr3. I think all of these are important for organic chemistry also. These act as Lewis bases in Friedel-Crafts alkylation acylation reactions. Then we have simple ones which are known as simple cations. Cation hai to positive charge, and there is a we can see that if there is a cation, that means it is electron deficient, it is electron poor. So we'll write simple cation. जैसे आपके पास Na+, कैल्शियम 2+, राइट, Ag+, H+, है ना, सारे के सारे क्या, these are Lewis acids. Then come those which have empty d orbitals. Empty d orbitals, इनका जो है ना, these are not incomplete octet, but they have vacant d orbitals. तो second period के बाद वाले, third period and onwards, they have vacant d orbitals and they can have some electrons there also. So SiF4 हो गया, SnCl4 हो गया, you can have PF5, all of these things are having empty d orbitals. Last case जो है, that is when you have, please write, atoms bonded to more electronegative element via multiple bond. तो यहाँ पे आएगा आपके पास कार्बन डाइऑक्साइड. So carbon atom is bonded to more electronegative oxygen atom via multiple bond. Similarly, you will have SO2, है ना, sulfur dioxide. This is also the same thing. इसमें आप लोग एक दो एग्जांपल लिख लीजिए, then we can conclude this. For example, आपके पास था BF3, okay? So BF3 में you have 3 fluorines and boron atom, plus you have NH3. NH3 is going to act as a base, Lewis base, और ये act करेगा acid की तरह. Why? Because it has a vacant orbital and nitrogen can give the electrons here. And you will form a coordinate bond in which BF3 has been given electrons from NH3. है ना, ये एक आपका सवाल सॉरी केमिकल बॉन्डिंग में भी है कि यहाँ पे इसकी हाइब्रिडाइजेशन इज BF3 is sp2, this is sp3, but BF3 इस केस में it has now 4 bonds and it becomes sp3. नाइट्रोजन is still sp3. ठीक है, एक और एग्जांपल लिख लीजिए आप with carbon dioxide plus OH negative. So OH negative का ऑक्सीजन के पास लोन पेयर इलेक्ट्रॉन रहता है ना, वो भले ही यहाँ पे दिखाया रहे, लेकिन it is on the oxygen atom. So it attacks on the carbon atom like this. One of the pi bond is going to break, and you are going to have carbon with a double bond O, single bond OH, and O negative. So this is HCO3 negative. Okay. So this is acting as an acid. This is acting as a base. Lewis acid and Lewis base to be specific. Is everything clear till here? Yes or no? Please tell me. Anji बताएं. Hibba, Abdullah, Wasiha.
Yes, sir.
Okay. अब थोड़ा सा इसको conclude कर देते हैं, ठीक है? We have learnt about acids and bases, और हमने 3 concepts पढ़ा है. We were talking about acids and bases, and we talked about Arrhenius concept. We talked about Bronsted-Lowry. And we also talked about Lewis acid-base concepts. Acids and bases. Arrhenius concept क्या कहता है? It should gives H plus in water. Bases gives OH negative in water. Bronsted-Lowry का कहना था, this is H plus donor, this is H plus acceptor. Lewis का कहना था, this is electron pair acceptor, एंड बेस का कहना था दिस इज इलेक्ट्रॉन पेयर डोनर। दैट्स इट फॉर टुडे। लिखिए सबने ये सुनो पीसल मी।
Yes, sir.
दैट्स इट फॉर टुडे। अब एक बात बताइए, कल एक क्लास होगी आप लोगों की, ठीक है? एंड हिबा आपकी कोई और क्लास होती है क्या कहीं और किसी दूसरे कोचिंग में कल?
So tomorrow,
हाँ यार टुमारो फ्राइडे।
I think in the evening, physics, I think.
इन द इवनिंग, ठीक है।
I'm not sure.
नहीं एक क्लास है, ठीक है। ओके वजी नहीं, हम लर्निवियो का छोड़ दीजिए, इसके अलावा कुछ और है तो वजीहा आप बताइए, डू यू हैव एनी अदर क्लास टुमारो? लर्निवियो का तो पता चल जाएगा हमें।